Hello there, welcome to lesson number 3 in our series on using FluidDesigner for 3D printing to create rings. In today's lesson we're going to show you how you can use a SuperToroid object to create a simple ring. So if you start off FluidDesigner, first thing we need to do is go to Learning Projects, Jewellery Projects, Rings. And we're doing lesson 03, so it's 03 SuperToroid. So if you just drag and drop that onto the workspace, I'll just start off the screencast keys. So any key presses I make should be displayed down here. And this is essentially the object that we're going to create in today's lesson. And as is usual, the instructions are in the help panel here if you don't want to follow the video. So we're going to add a mesh, and it's a torus object, and it's a SuperToroid. So add mesh, torus object, and we're going to do the SuperToroid. Now it's very important that this toolbox panel is open here. If it isn't, if it's shut down, you can always press T on the keyboard. T will open and close it, or you can just click on the plus sign there. Now the object that we've got on the screen at the moment in the center is very small. As you can see, it's only 2.6 millimeters by 2.6. But if we go to view and zoom to selected, you can see what shape it is. It's a SuperToroid shape, and there are some values that we can change to change the appearance of this object. Now the first thing we're going to change is the big radius. Well, I think it's pretty obvious what that's going to do. It's just going to increase the dimensions, the X dimension and the Y dimension of this object. So if I just hold the left mouse button down, you see I can drag that up. I want to go up to a value of 10. Not easy with the mouse to get 10. It's better to just type it in. So that gives us a bounding box object of 20.6 millimeters. So in other words, the internal diameter of this at the moment is currently about 20 millimeters. The 0.6 millimeters comes from twice the thickness of this. It's not exactly 20 millimeters on the inside, because the big radius is in fact the radius from the center to the middle of the SuperToroid. Okay, so we're 10 millimeters from the center to the middle of the SuperToroid. Then we've got an extra thickness of 0.3 of a millimeter, being the small radius. 10 plus 0.3 is 10.3. Twice that gives us an external diameter of 20.6. So we want to change the small radius, and in the help panel it says change this to a radius of 1. In other words, that's going to give us a thickness of about 2 millimeters for the object. So as you can see in the properties panel, the X and the Y are exactly 22 millimeters, so it's 10 millimeters from the center to the middle of the SuperToroid, plus 1 millimeter thickness, 1 millimeter radius from the center, so that's 11 millimeters, 22 right across, but a thickness Z of 2 millimeters. So the small radius is 1 millimeter up, 1 millimeter down, so that gives you a thickness of 2 millimeters. And that's important when you're 3D printing. You want to know how much metal, what the thickness of the metal is going to be, because there are minimum sizes. Now the next thing we want to change is the U segments. Well, if we just switch that right down, you can see what the U segments are. These are the U segments going around. There are 3 at the moment, so it's 1, 2, 3. So we can change that to 4. That gives us 4 sides, 5, 6, 7, 8. Okay, so we've not got a circle on the inside, we've got an octagon, we've got an 8-sided object. And the V segments, well, if we zoom in, the V segments are the number of faces going around this way. If I move that right down to 3, there are only 3 faces now, so it's got a triangular cross section. And in this exercise we're going to leave it as 8. So the higher these two values, the more rounded the object will be. The lower these two values, the more angular it's going to be. So those are the only values that we're going to change in this instance. So we can shut this panel down now. We're not going to make any more changes there. So at the moment we don't know exactly what the internal diameter of this is, but if I just, first of all, if I just delete the original one, so highlight it on the keyboard and press X to delete. One way of measuring this is to use the interactive ruler. Well, to do that, before we do that, we should always go to View and Top. And if we look up here, it does actually say top perspective. It's usually a good idea to switch from perspective mode to orthographic mode. That gives you a cleaner view of the object. You don't see it in perspective. You don't see the back of the object. You see a much cleaner view of it. So that's just a toggle from perspective mode. So here you can see the back of the object in this case. So any measurement we take there won't exactly be right. So it's always best to switch to ortho mode. Now we could measure across this using the interactive ruler. So we can click on that on the toolbar and measure across. And as you can see, that's only about 16 millimeters across there. So despite what this value says, the internal diameter is only 16 millimeters. So I'll press Escape key to come out of that. So let's imagine that we want an internal diameter of, say, 20 millimeters. The best way to do this, I'll just scroll back along the toolbar here. The best way is to use a cylinder. So if we add a mesh and a cylinder to the workspace, and we're just going to use this to measure the inner diameter of the SuperToroid. So if we change this to 20 millimeters, 20 mm and 20 mm, what we've done there is we've created a cylinder that's got a diameter of 20 millimeters. So if we now click on the SuperToroid, and we do need to make sure that we've got the SuperToroid highlighted, not the cylinder, it's the SuperToroid. What we're going to do is we're going to scale that up. And so to scale an object, we need to press S on the keyboard. And I just move the mouse away from the object. And as you can see, what I'm looking for is to points where the cylinder is just on the inside of the SuperToroid. So you can guarantee if your finger is 20 millimeters diameter, it will fit in there. It's no good measuring it across this point. It could end up being too tight at this point here. Now whenever you do scale in FluidDesigner, you always need to open up the toolbox, and what you'll notice, because we've resized it, these vector values have gone above 1. We've scaled it and made it bigger, so these vector values have changed to 1.205. They always need to be reset to 1 when we're printing in FluidDesigner. And the way to do that is hold down the Control key and press A on the keyboard and apply the scale. And when we do that, you'll see that this tick is in the box for scale, so the scale is reset now. So we can close the toolbox down. So you've always got to remember in FluidDesigner, if you're going to scale an object, always reset it. Control A and apply the scale. Now if I just select the cylinder again, we're not going to print the cylinder, obviously, we just use that to size the object. So I'll highlight the cylinder, press X on the keyboard and delete it. So here's my SuperToroid now. What I need to do is to save it. So always in FluidDesigner we recommend you go to Save As. Go up through the menu system. We're saving it in My Projects, Jewellery Projects, Rings, as Lesson 03 SuperToroid, and we save that as a Blender file. Now we can't print Blender files, so as is usual we need to export it, and we like to export it in the wavefront object format. I'm going to export it to the desktop, so it's 03 SuperToroid object. Then go to Netfab Basic. We always need to run our work through Netfab Basic, so go to Project and Open. Go to the desktop, open 03 SuperToroid. I wasn't expecting any major problems with this. There's no warning red triangles, but even so, always do extras and repair part. Netfab Basic, what it will do is it will triangulate this mesh. We can only print triangular meshes. And if I just drag the screen across there, if I click on Update, you can see there are no border edge problems, no orientations and no holes, but just run automatic repair and execute it. And apply the repair. Only takes a second to do, just to confirm that this is now a suitable format to print. So if you go to Part, export the part as a wavefront object, export it to the desktop, and this is now the file that can be printed. It's 03 SuperToroid repaired. So that's it. That's the end of this lesson. Thank you.